Good morning, guys. Welcome back. Today we're going to be looking at activity 40.1. We're looking at the addition rule for probability. Reminder, when we're looking at probability, we're looking at what are the percentages that something might happen. Okay, so like, flipping a coin, there's a 50% chance that you'll get heads and a 50% chance that you'll get tails, and we would represent that as 0.5 as a decimal. Okay, so the limitations of probability are between 0 and 1, as far as what are the odds that something's going to happen. And generally speaking, the odds that if we're looking at a particular event, right, the odds that event happens plus the odds that the event doesn't happen has to add up to 1. Okay, so when you flip a coin, you've got 0.5% chance that you're going to get heads, 0.5% chance that you're going to get tails. That's going to add up to a total of 1. And that's what's going to happen with all of our probabilities. So keep that in mind when you're working the problems and you're like, I'm not sure how to kind of finish it up. It should all add up to 1 when you've got all the possibilities listed. Okay, so we're on page 581. I just wanted to kind of run through kind of a reminder of some stuff that you should have already seen. Probability notation. So if you see something like this is P of A, so probability that A will happen. A is just some random event. Could be that you have red hair, I don't know. Just some random event, doesn't actually matter what it is. But that's the notation, and again, it's between 0 and 1. You don't have a negative probability. Your probability could be 0%. Let's say, for example, the probability that you were born in 1873. Well, that's a 0% chance, right? Because not going to happen. So then we have some other notation here. We have the or notation. So the probability of A or B, and that is used kind of a U symbol there. And then probability of A and B, and this would be kind of with an N. And then this is one that people tend to forget, probability of not A, right? And that's kind of the way it's said. The probability that an event doesn't happen. And remember, I mentioned the idea that the probability of an event happening plus the probability of the event not happening has to add up to 1. And so if you ever want to know what's the probability of the event not happening, let's say there's an 86% chance that it's going to rain. That means there's a 14% chance that it's not going to rain. Very straightforward, very easy. One other thing I wanted to show you on some of these is if we were looking at Venn diagrams, and so I'll just draw them real quick. Let's say we had a Venn diagram like this, and this is A. If we're looking at probability of A, it's the entire A circle. If we're looking at probability of A or B, so the same Venn diagram, here's A, here's B. If we're doing A or B, we're going to shade in everything inside of both circles. If we're doing probability of A and B, that's just going to be the overlap. Okay, with this being the A and this being the B. And then the probability of not A, so if we had the same drawing, here's A, here's B. Not A is everything outside of that circle. So it includes the stuff that's in B that's not in A, and includes everything else. Okay, so this one is kind of interesting. Now what I want to do is run us through kind of an idea, just to remind you how you find some of these values, because I'm going to let you kind of work through and deal with some of these problems. But we're going to do a practice problem first. So here we have the probability that you have a dog versus probability, or sorry, the event A is that you own a dog. Event B is that you own a cat. Okay, and so we're going to look at, and this is just some random sampling. Okay, so a few questions I have here. First, if we're talking students, right? So this is number of students in a particular class that own dogs, number of students that own cats, right? How many students are in the class? Well, you would have to add up all of these values. Just as a reminder, you did that in the last section. So 10 plus 7 is 17, plus 3 is 20, plus 5, so there are 25 students. Okay, now, how many of those have dogs? Well, A is going to be our dog representation. It's both of these together. So how many of them have A? That's going to be 17 total. Okay, so this is, and we could call this just dogs. Let's call it what it is. All right, cats, a little less. We have 3 and we have 7, so we'd have to add those together, 10. How many people don't have a dog? Well, what you could do, there's 2 different ways to do that, is you could add up everything that's not in A, which would be these 2 together, okay? Or you could look at the total minus how many do have dogs. And that's going to give you 8, which would be the 5 plus 3, okay? So this would be a complement. Complement's kind of the math word we use. A complement means the opposite of. So A complement is going to be equal to 8, all right? So if we were talking about probability, these are just straight up numbers. If we're talking about probability, there are 25 students total, right? So every student is 4%. So if we wanted to know the probability that somebody has a dog, which we said we're going to use the letter A, the probability that somebody has a dog, well, there's 17 students that have a dog, so that's 17 times the 4%, or 17 over 25. And so that would be 68.68. All right. Probability that somebody has a cat. And I use these letters on purpose because I don't want you to associate the A and the B. Like I didn't want to use D and C. I want you to realize A stands for dogs and B stands for cats. Okay, the letters aren't always going to match up. But the probability that somebody has a cat, well, there were 8 people that had cats. And so that's 8 over 25. And so that's 0.32. Okay? So, questions about that? Sorry, bad teacher. Not 8. I can't add. This is supposed to be 10. So this is 0.4. Okay? Now, let's go through this other notation we had. We had the OR notation, probability of OR. Well, how many of them are OR? So probability of A or B, that's not an OR symbol. That's an OR symbol. It does matter. Hopefully you can see that on there. And that's going to be all of these. Okay, so the 10 plus 7 plus 3. So we're going to get 20 over 25, which is 0.8. So here's my question. Here's the thing. What is the relationship? Obviously, probability of A plus probability of B, does that equal the probability of A or B? Well, think about it. This is 0.68 plus 0.4, and this is 0.8. Well, 0.68 plus 0.4, that's going to be more than 0.8. How much more? Well, this is 1.08, so this is actually more than the whole thing together, so there's something wrong there. We need to figure out how to balance that. What's happening? Well, let's look at one more thing that's not listed on here, and let's look at the probability of A and B. That's the 7 in the middle. That's that center overlap, right? So 7 out of 25, which is 0.28. And that's what we're missing here. And this is what you're going to get to discover in this section, is that you need to get rid of the overlap. Why are we getting rid of the overlap? Because it gets counted twice. Think about it. When you count A, you count the 7. A is 10 plus 7. Well, B is 3 plus 7. The 7 gets counted twice, so we need to get rid of that 7. So this is what the notation looks like. This is considered, this is the addition rule. Probability, guys. And just to kind of help drive that home and to kind of concrete that for you, I want you to start on page 581. You're actually going to work 1 through 7, and then come back to me. At the end of 7, you're actually going to fill out the addition rule, just what we kind of just did. So you kind of got a preview of that. But I want you to work 1 through 7 and then come back to me. Let's say 10 minutes. All right, I'll see you in 10 minutes and we'll go over it.